Hey everybody, this is Larry. This is day 11 of the April Daily Leetcode Challenge. And today let's look at the diameter of the binary tree. Given a binary tree, you need to compute the length of the diameter of the tree. The diameter of the binary tree is the length of the longest path between two nodes in the tree. This path may or may not pass through the root. Return 3, which is the length of the path uh, 4213 or 5213. Okay. Um, yeah, so there is a trick kind of to this problem. You could probably do a different complexity profile, but you can actually solve this with just two depth first search. You depth first search to find the farthest node, and then you do a second depth first search from that node, and then that will be your answer. So let's just implement that then. Yeah. And you could uh, and you can prove to yourself that that's true. And right now I'm just thinking about how to actually implement it. Just keeping in mind that I think a little bit of a trap may be to think that the farthest or the longest path might go through the root, but that's not necessarily true. Um, but as you can imagine, the farthest from the root uh, would have to go would have to be a leaf. Yeah, I'm just trying to think about what is the best way to solve this with respect to back edges. But yeah, let's go. I'm probably doing one DFS. And I'm still setting up. I'm trying to use this to also set up the nodes. So let's say we have this done. And now we can do another DFS of any node. And then now we just do another DFS. But now we go in all three possible paths. But this time we should keep track of the stuff we've seen because now there are cycles. We just need the length, so and you can of course set this up in a without mutating the nodes, but that's how I'm doing it for I think for now. I guess we actually don't need to follow this node over this problem, so none, is it? Double check real quick. Hmm. This is where a debugger would help, but on an interview you probably don't have access to a debugger. Take this long either. The server's probably having some issues, but Oh. Of course. Just silly mistakes. From Python 3. Well, more specifically, my forgetting how local functions work in Python 3, but testing is a little bit slow today, but that's okay. And of course, as usual, we should get some testing going on. Though on this particular problem, it's a little bit trickier to is it no or none? I don't know how. And this is just Leetcode specific, where I actually don't know how they want it. No, it feels weird writing nil in or no in Python 3, but test case is not related to that. Yeah, so ideally this should be 5, right? But if you go through the root, then this would not be 5. Actually, it would still be 5, so I need to be a little bit longer. I lied. 4, really? Oh, 4 edges, 5 nodes in the biggest set. More like that. Okay, let's just submit it. And, ooh, news. Have a debug time. Data too large to be displayed. Hmm. Hmm. Maybe my type working rules are bad. Let me think about it for a second. Yeah, I guess so. I remember that that algorithm being you could choose any of the farthest nodes, but is that true? Okay. Hmm. I clearly still have another typo. I guess this is the case where it doesn't go through the root, but obviously the farthest path from the distances from the farthest distance from the root should be big, more than 0. Hmm. What does this give me? Just give me a random root node. Hmm. Oh, I have a typo, like literal. Okay, well, sometimes that is, I suppose, one advantage of using a statically typed language. These things don't happen. A compiled language, maybe. I'm a little sad about that one. But okay, let's try again. Um, okay, cool. Um, I'll say a couple of things. One is, well, know your algorithms. You probably, I don't actually know how well known this algorithm is. I feel like it's a little bit unfair if you don't know this algorithm. Then you probably there are other ways to figure it out, um, and maybe you could even do an n square algorithm, and that's maybe okay. At least talking about it and talking about strategies to get the optimal answer. Right now, because I do 2 depth first search and each use all of n's extra space, to keep track of used for my depth first search. Um, this is O of n space. You can actually also implement this another way where you just don't go back to the parent, but because this is a tree, but because of the stack space, it's still O of n space, so it's going to be linear space, linear time, which is pretty okay. You can also obviously use breadth first search, just do the same strategy, but breadth first search, and it'll give you the same complexity. I think one thing, and this is a very interviewee problem, so I would definitely recommend practicing it. I think one comment I have for this is that when you run into an issue, don't despair. Just stay calm and think about where things could go wrong and debug it. I'm not gonna lie. When I was going through the debugging, I was second guessing my algorithm a little bit because this is not at least for me, this is not something that I practice as much as I could because this is a very, well, the depth first search part I practiced though. I end up getting that a little bit messy because of the typo. Um, but because I wasn't sure, it's been a little bit to do a diameter of a graph or of a tree. So I had to second guess that one. I was like, oh, am I wrong? Why am I typo? But and this is also if you are in production, you're writing production code and you're using a reasonable IDE and you have a debugger set up. This is way uh, like the reason why you have these bugs are very obvious. But instead, I had to resort to print statements for a little bit. Um, but even then, it showed that like, oh, there's something wrong with this, and it just turns out that I did not set the farthest distance. Um, but yeah, overall, definitely recommend and also practice depth first search, practice breadth first search. Do it both ways if you're having issues. And yeah, overall a good problem, a good interesting problem. Yeah. Thanks. Hit the like button, hit the subscribe button, hit all those buttons. See you next week or tomorrow or whatever, whenever the next daily challenge would be. Bye bye.